Okay, this was our equation, and look, Gerchevanov studied this equation where AX is it's a function. So this was again on the real line. This is a challenge to do this. And this was, you can see. I am curious. I had no time to look on the, when I try to find what other mathematicians did, usually, and I suggest you to do the same, usually I go to this paper, and in some databases we can find citations, so we can see. For example, papers by Professor Viramani, if you look, hundreds of citations. So in order to know if you can do something there, you should check, because hundreds of mathematicians had work on, for example, on cyclic or on best proximity. So it's not easy, but we look to what other mathematicians did, and we can decide if we have chances to do something new. So this is a new topic. So it can be done with almost the same means. In my opinion, it works without any change, just we need to take care of this A of X, which in our case is the identity, so it's 1. So this is not easy to, then in order to reach an approach to this equation, maybe first we should go to this equation, which was studied by a Romanian mathematician, Germanescu, in '56. And what he did here, you see, we had only, he had constants, A0, A1, A2, AN are constants. I did not mention here. And he used G of Fx, G of F2 are the iterates, and this is more closer to our fixed point approach because the iteration is here, and he obtained very interesting results. So these are two types of functional equations at least, but we can combine also these ones. So this is the application of almost contractions to functional equations and to of weakly Picard operators to functional equations. Of course, that this is not a typical application of fixed point theory, and most of us are now interested to find application in machine learning, data science, what is now of current interest. But always you'll see that such a problem can be related to some current topics of research. It is my belief, I know in my country there are some mathematicians, they say, you are working in this topic. This topic is not of relevant interest. Or another one, this topic, this is an old and not fashionable topic. This is not, I do not agree with such an opinion. I consider any problem, any mathematical problem is of interest, and we can work on it honestly, and we can try to do something new. And on such kind of problems, just be honest with yourself and tell me, if you look at this equation without knowing anything about it, how could you approach it? It's not easy. So we look at it and what to do. How we were suggested this series we had in the proof. How was constructed this series? This is the question, B here, sorry. B and the others. And there is no easy to see how we construct this series, and how we do in this way. A normal approach is to do G of fx. Okay, then we take instead of x, f of x. Then it will be G f of x plus G f2 of x. Right? And we continue, and we'll have G, how is in the, it's Fn. So G of, it should be Fn minus 1 of x plus G of, n minus 2, Gf n minus is 1, 2, and Fn is right. Let's see. No, it's not correct. So here it's x fx x is n minus. So I write one more. N minus 1 G of Fn equal f Fn. So this is the approach. Then we sum all. What happened? I multiplied this by minus 1 because I intend to have them cancelled. So the next one by minus 1, and so on. This one will be multiplied by minus 1, maybe to n minus 1, and how is there? Minus n multiplied to minus 1 to n, and we sum, and we should get exactly our series. So the rod from the original functional equation is this one. So we applied actually an iterative approach to reach this series, and this was the secret of the solution of this functional equation. So to anticipate and to find this series, and then to study the convergence of the series. So let us conclude all for this topic. Because I mentioned Maths Connect, what kind of knowledge we collected in this application. So first of all, we had functional equation. Then, in order to tackle this problem, we had fixed point theory. Then we had theory of series. Okay, and and here also summability, which is an advanced field summability of series. And in this way, we were able to solve. So actually, three fields unified to solve a problem. When we consider other kind of applications, if you consider now this machine learning, maybe I'll try to speak about some relation Maths connects to of fixed point theory to data science. I forgot. I promised you, but I forgot. Then we can see how we can relate these two fields apparently totally different. Fixed point theory, data science, fixed point theory, machine learning. Fixed point theory has very important, by the way, in theoretical computer science, it's extremely, extremely important, fixed and point theory. Mainly, I take this time because there are a few minutes until the break. We are all familiar with metric spaces, but there are many generalized metric spaces. One such metric is, how is called, not quasi-metric.
What is the condition?
It's in computer science. I don't remember now the name of this. Partial, thank you. Partial metric.
0 and 1.
Yes, partial metric. It has been introduced in computer science, and I have in work a paper. We work on it by half a year now with Professor Roos to the applications of generalized metrics in theoretical computer science and formal languages. A lot of application. For us who are working in fixed and point theory, partial metric spaces are not relevant, in the sense that any partial metric generates a metric, so for us it is done. So we can convert any result in, but for them it is very important, very important. And also I'll speak to this conference Maths Connect about this very important generalization of metric spaces, B-metric spaces, which is extraordinarily important also in combinatorial optimization, in graph theory, in celestial mechanics, in astronomy, a lot of interesting application. But this structure, this setting, is also very important for fixed and point theory. There are hundreds of papers in the last. I'll tell you just a few words because I'll have no opportunity to speak later on this. I worked on this in 1993. There was another mathematician, Czerwik, a Polish mathematician, the same year. My paper was published in Seminar of Fixed and Point Theory. It was not so visible, but his paper was very visible. It's extremely cited, extremely highly cited. And he has another one, 1998, I suppose. And recently I published a paper about these B-metric spaces, and I discovered that I was at a certain time persuaded that the first paper, the first fixed and point theorem, was in this year, Russian mathematician, Bakhtin. But recently, maybe 2 years ago, I discovered that it is not true. The first fixed and point theorem in such B-metric spaces, exactly the Banach fixed point theorem in B-metric spaces, was established by other Soviet mathematician. By the way, this is a Romanian one, but in Republic of Moldova. Moldova, it's a part of Romania that was taken by Russia 200 years ago. And Russian, what they take, they will never give back. So this is the Russian principle. Yes, yes. And Vulpe means fox in Romanian. So Vulpe is the name of this mathematician. And actually he was the first one. The second one was Bakhtin. He was not aware of this paper. And Czerwik knew just the paper by Bakhtin. I knew just the paper by Bakhtin, and I extended this. And so, to close our session, first morning session. So I would like to say that sometimes a result in fixed point theory, which is not really significant, can have relevance in another field. So for example, for this simple case, weakly Picard operators is not a big deal, but here are essential. Picard operator here are essential. The same partial metric spaces in our theory are not relevant because we can construct immediately a metric and the result is equivalent in a metric space, but in computer science it is relevant. So do not disregard result. Any kind of result can have some relevance. This is my personal opinion, and I do not agree with people I mentioned before that say, this is not relevant. This is not relevant mathematics. This is old. This is not fashionable. Now it is fashionable to do this. And mathematics, any kind of mathematics is valuable, and just to be sure, it is new. So maybe some questions. We have time. Yes, we have time for some question, if any. Please feel free to ask.
Yeah, very, I think, informative talk by Professor Brende. If you have any, like, I think he elaborated a lot of things here, especially the starting from the functional equation. The fixed point actually originated from the functional equation, and he was touching the Mann iteration, that you have seen that. Later on, some applications, this iteration kind of things using this operator, and some of the hidden, actually I can say, the researcher whose name not so visible because of the low circulation of the journals, but their works are very nice. Like I think this Professor Kannan also, R. Kannan, his result was published in Bulletin of Calcutta Mathematical Society for the discontinuous functions, and not that much visible, but once he left to US, then you see the difference. And you will be wonder to know that actually he joined in physics.
In physics? Not in physics?
No, first he joined MSc Physics. After that he left physics after some time and joined MSc Mathematics in Calcutta University. I think Professor B.K. Lahiri is his supervisor. Yeah, Professor Kannan's. So that's why I knew. And since my thesis went to Professor B.K. Lahiri, that's the reason that I am very much connected to Professor B.K. Lahiri. And his very small, some 125 pages functional analysis, and in that you can find very good examples. Like he says, examples means they should be very easy to understand first. So that is true. So any question from the audience in this regard? Yeah, please.
Sir, when you were explaining the result by Roos, your supervisor, there was a result and A and B, two parts. So in part B, it was A and B both must be fixed points. So it is necessary that A is also required?
You mean this initial example?
Yes.
This one?
Yes, this one.
Is not essential here. Here, the authors I mentioned, they wanted to avoid this fixed point because they wanted only one fixed point. They were not able to treat. So what they said, they consider only this. You see, here it's not excluded. I is excluded to not be a fixed point. It's not essential. But in my considerations, this example is all right. So A can be a fixed point. This is the question.
Yes, and also this the third condition, if x is strictly greater than x. So
Oh, of course, it's not essential. So I said this is not, any one of these are not necessary. These were given just for the sake of solving this problem. So this mathematician, Malenica, this is a Serbian mathematician, he needed this function f, and he forced to have this structure. So he assumed in his main theorem, these are the assumptions on f. But as I said, these assumptions all are not necessary, are just sufficient for this conclusion. So this was needed actually for him. He needed this, and this was why he excluded A, because if x is A, then what happened? Limit of n of A is A. So he wanted to exclude this. So this was not the general case. So this offered me the opportunity to extend. This was the, as I said yesterday, we have to go deeply into such an example, into a theorem, and to see what is sufficient only and what can be, what is necessary. So here, the only necessary assumption, which is actually a conclusion, is this one. This was the only necessary fact. The other were all sufficient to ensure this. And the point was how to ensure this in a general context. And in the general context was to consider a Picard operator or a weakly Picard operator. This means a fixed point theorem. So behind these are fixed point theorems, but I did not mention. So because we discussed yesterday. So normally we should say that for the mapping I considered here, we have this fixed point theorem. Where is? So for this case, I will say that we have f, which is satisfying a certain condition and has fixed points and so on. So, all right? The answer? Okay.
Yes.
Did someone solve this elementary functional equation? This one for students in secondary school. Do we have still 1 minute?
We have.
Okay, we have 3 minutes. So
Yeah.
I came back to this functional equation. Did someone? Something? You had no time to think about. It is very easy. We just change x to be 1 minus x, and this will be our f1 minus x, and this we should x 1 minus x, x minus x plus 2. And we can see, we can solve this system. It's a system. And we can find directly fx if we solve with respect to this unknown. This is a very nice elementary problem. Okay.
So if no question, so this session is really a very innovative session. A lot of information we have received, especially that area, particularly Romanian. So you can understand that Romanian mathematics is also very sound mathematics, and especially they have worked in functional analysis, particularly deep mathematics is there. Okay, so I should say thanks to Professor Brinde for this session. Thanks.
So this will be the second one. Okay. Thank you.
So now 15 minutes for the tea time.